Hi everyone, Algebra 2, 2-6, transformations of a function. Okay, first thing we're going to talk about is shifting, which we call the translation. So I have this reference paper available on your canvas, so you can print it out, take a look at it. Shifting, shape doesn't change. You move it either to the right, left, up, or down. We call that as a translation or shifting. So if you talk about x square graph looks like a parabola like that. How do we tell the shifting or translation from equation? We are adding or subtracting a number. If x cannot see that number added or subtracted, if x cannot see it, that's not related to x. X-axis is a horizontal axis. If x cannot see it, it has nothing to do with x. That means it has a thing to do with y. Meaning it's going up or down. If x can see the number added or subtracted, then x has a thing to do with that number. Meaning we are shifting either to the right or left. So it's all depending on x can see the number, x cannot see the number. So you might say, what do you mean x can see, x cannot see? So y equal to x squared is a parabola. So you need to know this y equal to x squared. This is a parent function, several kinds of parent function. Y equal to x squared, you need to understand this is a parabola. If you go one to the right, you go one up. You go one to the left, you go one up, because 1 squared equal to, if you plug it in 1 for value of x, it's 1 squared equal to 1. So 1, 1 minus 1, 1. Of course, if you plug in 0, you got 0, 0. Okay, so you need to know basic shape of that. So knowing that, you should understand we are adding 3, we are adding 3, we are subtracting 3, we are subtracting 3. So we are adding a number, subtracting a number. That's what I meant by I'm adding or subtracting. That means it's a translation, shifting. So when you look at plus 3 versus plus 3 here, okay? When you look at this plus 3 versus this plus 3, my question is, can x see 3? Yes or no? Can x see 3 here? So top one, yes, x can see 3 added. Bottom one, x cannot see 3. So someone might say, well, how come x cannot see 3 there? They are right next to each other. X is under the square. X is square. So square is covering x. X cannot see anything outside of the square. That's what I meant by x cannot see 3. Okay? X can see 3, they are both under the square. So x and 3, they can see each other. So you should understand that's what I mean by cannot see, can see. So if x can see the number, it's shifting in terms of x-axis. Either you move to the right, move to the left. Okay? So it's a plus 3. Are we going to the right or left? So in x-axis, right is positive, left is negative. So when you have x plus 3, you attempt to say, yeah, plus direction is right, so you're moving right by 3. So be careful with that. X is always weirdo. X is always weirdo. If x is minus 3 here, you go right by 3. If it's x plus 3, you go left by 3. Okay? So for this one, I can say left by 3. Translation or shifting left by 3. Let's go back to this guy. x cannot see 3, then means this is the one has nothing to do with x. So it should be up or down. Plus 3 vertical is just straightforward. Plus 3 you go up, minus 3 you go down. So x squared plus 3, this is going up by 3. Same logic, when you do minus 3 here, you should pay attention. Can x see minus 3? Yes, x can see minus 3. What does that mean? That means minus 3 has a thing to do with x. Either we are shifting to the right or shifting to the left. Minus 3, you gotta go opposite direction. You gotta right by 3. X can see minus 3? No. Has nothing to do with the x. That means either up or down. Minus 3, you're going down by 3. Okay, so graphically, you got square root of x squared, which is a parabola, up, down, right, left, you know the shape. Okay, pause the video, please. I want to try this by yourself. Okay. Absolute value of x, absolute value of function looks like a V shape. Okay, if you didn't know, you need to know. So 0, 0, if you go 1 to the right, 1 up. 1 to the left, 1 up. But shape looks like a V shape. That's original function graph. I'm asking to figure this out. Okay, so plus 2, yes, can see it. So it should be left by 2. X minus 2, yes, x can see it. You gotta go right by 2. X and 2 cannot see it. You gotta up by 2. X and minus 2, x cannot see it, down by 2. Okay, so if you got this, then you should be able to handle something like this. Describe the translation of y equal to this as it related to parent graph, then graph the function. Parent graph is without shifting. So you should understand, okay, parent graph should be just equal to y equal to x squared is parent graph. Plus 1. X can see 1? Yes. So it's either right or left. Plus 1, where do we go? Opposite direction, you remember? You gotta go left by 1. Left by 1. Okay? So your graph should look something like this. You go left by 1. From here, you go right 1, up 1. Left 1, up 1. So you got the shape, something like that. Now you try this. Of course, parent function will be y equal to x squared without considering minus 1, without considering minus 3. Okay, that's x squared is a parent function. Graph, what happened to the minus 1 here? Right by 1. Minus 3 here, down by 3. Because x and minus 1, they can see each other. So it's about x, either right or left. Minus 1, you gotta go right, opposite direction. Minus 3, excuse me. X cannot see minus 3. So it's a vertical. Minus 3, you go down by 3. So if they ask you graph it, here's what you can do. So on a piece of paper like that, you go right by 1, down by 3, 1, 2, 3, and you go right by 1, up 1, left by 1, up 1. If you go right by 2, 2 squared makes a 4, right? So if you go right by 2, you go 1, 2, 3, 4. Usually I just do 3 points. Then that's gonna be good graph. Okay, next topic I need to cover is reflection. So again, I have a paper, reference paper like that. Reflection, so square root of x graph looks like this. If you reflect that over x-axis, graph will look something like this. That's what I call the reflection of the x-axis. So original graph of square root of x is this. If you reflect it over y-axis, it's going to look like something like this. How do you tell in equation-wise with reflection over what? That's multiplying by -1. That's how you express an equation. So if you look at it, square root of x minus square root of x versus square root of x square root of minus x. So it's again, x cannot see the number -1 multiplied, reflection of x-axis. X can see, yes, x can see the number multiplied by, then it's a reflection of a y-axis. You just have to memorize it. X cannot see the number -1, reflection of x-axis. Yes, x can see it, reflection of a y-axis. So if I ask you, one is reflection of a y, one is a reflection of x-axis. Let's say given parent function of like y equal to x squared. So we multiply by -1, we multiply by -1, both of them. My question is, do you think x can see -1 here? Yes or no? Do you think x can see -1 here? Yes or no? Here, answer should be no. X cannot see -1. You might say, how come they cannot see each other? -1 is right next to the x. This is exactly same writing as -1 times x squared. That writing is same as this. Square is covering x. X cannot see -1. X cannot see -1. So that's what? Reflection over x-axis. X can see -1? Yes. That's a reflection over y-axis. So you have to just memorize it. X cannot see over x-axis. X cannot see over x-axis. Okay? Graph-wise, this original graph looked like something like this. That's y equal to x squared. So reflection of a y-axis, think about it. If you reflect this right-hand side to the here, that's going to match. If you reflect on the left-hand side here, that's going to. So when you reflect over y-axis, the graph won't change. It's going to be exactly the same like this. Reflection of x-axis, though, you're going to flip it. That's going to look like something like this. 0, 0 doesn't go anywhere. But these points should be flipped. Okay. Okay. Pause the video. You do this. Which one is a reflection of a y-axis? Which one is a reflection of x-axis? So it's all about, as you can see, it's multiplied by -1, multiplied by -1. It's all about, can x see the -1? Multiply. X can see -1? No. X can see -1? Yes. X cannot see anything outside of the root here. That's why they cannot see each other. Cannot see is a reflection over x-axis, right? X cannot see that reflection of x-axis. You have to memorize it. But this one should be reflection over x-axis. This is a reflection over y-axis. And graph, you already looked at from the, this is a graph of square root of x, reflection of x-axis here, reflection of y-axis here. Okay. We already did this. And we did this. Oh, the graph we didn't do it, huh? Okay, so that was a reflection of x-axis. We flip it, so V shape upside down. This one was a reflection of a y-axis, so that's not going to change. V shape. If you, this is the original shape. Okay, but when you flip, that's exactly the same shape. So reflection of a y-axis. Shape of the graph will be exactly the same as original. Okay, next topic is stretch or shrink. So I have a reference paper here. How can you tell vertical stretch, vertical shrink, horizontal stretch, horizontal shrink by equation? Multiplying by positive number is related with dilation. dilation, stretch, shrink. Again, x cannot see the number, then it's a vertical, stretch or shrink. X can see the number multiplied by, it's a horizontal stretch or shrink. If the number multiplied by is bigger than 1, it's vertical stretch. Less than 1, vertical shrink. Horizontal, do you remember x is weirdo? If the number multiplied by is greater than 1, you are tempted to say horizontal stretch. No, horizontal shrink by reciprocal. Okay? So if the number multiplied by is less than 1, you are tempted to say shrink, but it's a stretch, horizontal stretch by reciprocal. So let me just give you an example of this. Y equal to x squared, what does graph look like? Again, the graph looks like y equal to x squared graph looks like this. You go 1 to the right, 1 to the left, you go up 1, left 1. This is the graph. Okay, 1, 1, minus 1, 1, 0, 0. That's the graph of y equal to x squared. So when you encounter a question like this, my question is, so multiply by 3 here, compared to this, changes will be multiplied by 3. My question is, can x see 3? Yes or no? It should be yes. This one, comparatively here, can x see 3 here? Many students make a mistake. Yeah, they can see each other, and that's wrong. X cannot see 3. X can see 3 here. They are under the root square together. X is under the square. X cannot see anything outside of the square. So X cannot see 3. Okay? X cannot see? Yes, X can see. If X cannot see 3, 3 has nothing to do with X. Then what does that have thing to do? It has thing to do with Y. Yeah, just to remember, Y is a vertical. So that should be vertical. We say vertical. Stretch or shrink. 3 is a big number, bigger than 1. So it should be vertical stretch. Vertical stretch by 3. Okay. If X can see 3, it has a thing to do with X. So it should be horizontal. Either stretch or shrink, it should be horizontal. So horizontal. 3 is a big number, bigger than 1. So you are tempted to say horizontal stretch by 3. Do you remember horizontal? X is always weirdo. So 3 is a big number. You don't go stretch. You gotta go opposite. So it should be horizontal shrink or compression by 3. Flip it. 3 is the same as 3 over 1. You have to take a reciprocal of it, which is 1/3. So it's a horizontal shrink by 1/3. Okay? Now, when you multiply by 1/3, first question you have to ask yourself is, can X see 1/3? Yes here. Can X see 1/3? No. For same reason. X is under the square. X cannot see anything outside of the square. X cannot see 1/3. 1/3 has nothing to do with X. That means it's a vertical. 1/3 is in decimal 0.33, less than 1, smaller number. So smaller number, shrink. Vertical shrink by, as it is, vertical shrink by 1/3. Okay? 1/3, can X see 1/3? Yes, they can see it. That means it has a thing to do with the horizontal. It has a thing to do with X, horizontal. 1/3 in decimal is 0.33, which is less than 1, smaller number. Stretch or shrink. Smaller number, stretch. You gotta go opposite direction. Okay? If that's confusing, take a look at this reference paper. Okay? Horizontal, A is less than 1. It should be expand, which means stretch. So you got horizontal stretch by, flip it. Cannot stretch by 1/3, doesn't make any sense. Stretch should relate to big number. Shrink should relate to smaller number. Horizontal stretch by, flip it. So 3 over 1, which is 3. Okay? Okay, so I also want you to understand what it means by stretch shrink graphically. So if you look at, for example, let's say horizontal shrink by 1/3. So this is a graph of y equal to x squared. What if I ask you, what if I ask you to graph this guy, horizontal shrink by 1/3? Horizontal is going to affect x. So graphically, you're going to just squeeze the graph horizontally. That's what's going to happen. So all horizontal shrink by 1/3, all x value you're multiplying by 1/3. What does that mean? So 0, 0, x value here, you multiply by 1/3. This doesn't change. X value here is 1. You're going to multiply by 1/3. So you got 1/3, 1. X value here, you multiply by 1/3, you minus 1/3, 1. Y value doesn't change. Okay? So if you graph it, it's going to look like something like this. Here's a 1, here's a 1. So your graph would be something like this. We're going to squeeze it. Because this is 1, 1/3 should be something there. That's what it means by horizontal shrink. Okay? So if you're talking about horizontal stretch by 3, imagine horizontal stretch by 3, then you're going to multiply x value, x value, x value by 3. So if you multiply by, so that was the graph of y equal to 3, y equal to 3x parenthesis square. So if I were going to graph this 1, 1, 1 will be 3, 1. Because x value, x value, x value, you're going to multiply by 3. So I don't want you to get confused. So 0, 0, it's going to be 0, 0, because multiplying 3 to 0 is not going to change anything. Multiplying by 3 to 1 here, x value, that will become 3, 1. Multiply by 3 to minus 1 will be minus 3, 1. So what am I saying? Your graph would look like 0, 0 doesn't go anywhere. You go 1, 2, 3 to the right, 1, 2, 3 to the left. Here's a point, here's a point. So your graph would look like something like this. You're gonna like stretch this graph. You're gonna grab it, stretch. That's what I mean by horizontal stretch. Okay. So probably you got the idea by now. Vertical stretch means you're gonna multiply to y value. So like this. Vertical stretch by 3, then you're gonna leave x values just alone. Y value, all y value, you're gonna multiply by 3. So if you're trying to graph, let's say y equal to 3x squared, the points gonna be 1, 3, minus 1, 3, 0, 0. Okay. So if you have y equal to 3x squared, so you have 0, 0, 1, 3, because you multiply by 3 to y value, which will be minus 1, 3. So you have 1, 2, 3, here, here, here. So your graph would like stretch vertically, right? So you're gonna grab this graph and you're gonna stretch vertically. The overall graph would look something like this. Okay. Okay, vertical shrink by 1/3. So this one is gonna be exactly same, except here. So y equal to 1/3 x squared. So y value multiplied by 1/3. Y value multiplied by 1/3. So it's gonna look like something like this. 0, 0, should be 1 comma 1/3 minus 1 comma 1/3. So your graph would look like something like this. Okay. So vertically, you're gonna squeeze it. Squeeze. Okay.